So friends, we were at this point in last lecture. We derived that if Pi and Qi they are the powers, real and reactive, being injected into the bus, then Pi minus JQi can be given by this expression. Modulus of Vi into modulus of Yij into modulus of Vj at an angle delta j minus delta I plus theta I. What is theta ij? Theta ij is the complex angle. Theta ij is the angle associated with the modulus of Yij. So y11, y12, y13, these are all the quantities of the Y bus, okay, of row 1, column 1, row 1, column 2, row 1, column 3. So like that, this is in general Yij is the ith column, ith row jth column entry, and this is the modulus, and this is the angle of that entry. So this is what we had derived. Now I can write two equations for this by separating out the real and imaginary part. So I can say that I will add a new page. So I can say that Pi can be given as real part of this equation. So real part of this equation is this sigma will remain, this Vi Vj remain, and this will be cos of delta j minus delta I plus theta I. So modulus of Vi, modulus of Vj, modulus of Yij into cos of, rub this, it is not looking good, cos of delta j minus delta I plus theta ij, theta ij plus delta j minus delta. J equal to 1 to n. And what will be Qi? So Qi will be all this into sine of this angle will be minus Qi. So if I equate the real and imaginary part, so Qi will be minus of this quantity. So Qi I can write minus of modulus of Vi, Vj, Yij, sine of, instead of cos it will be sine, theta ij plus delta j minus delta I, right? So cos of this will give the real and sine of this will give the imaginary part, but that imaginary part is equal to minus Qi. Minus JQi will be equal to the imaginary part. So I have to have Qi as minus of this delta j minus delta I plus theta ij sine and minus of that. So here also j equal to 1 to n. So now as you can see, these are called as static load flow equations. So we can write, if there are n buses in the system, we can write 2n such equations. And these equations are called as SLFE, static load flow equations. Why it is called as static? Because as you can see, there is no dependence on time in any of this equation. Is there any dependence on time? No. The time t is not coming into this. So it is all static. Otherwise it would have been dynamic equations. So since it is static equations, we call it as static load flow equations. And why load flow? This Pi and Qi indicates how the real and reactive power is injected into the bus. So for each bus we can write two such equations. Therefore we have got total how many equations? We have got 2n equations. 2 multiplied by n. So for each bus 2 equations. If there are n buses, 2n equations. And this, if we are able to solve, we should be able to solve the load flow solution. That, as we had seen in the here, that there is a Y-bus network equation. What is the load data? What is the generator data that we will input? And it will give us voltage magnitude and the power flow in each line. So voltage magnitude and phase angles. Power flow in each line can always be found out if we know what is the voltage across the two buses. Then we can always find out what is the power flow. So that is the secondary output. Primary output is voltage magnitude and phase angles. So in this, what are the unknowns? Since this is the output of the load flow program, this voltages will be the unknowns. And theta ij, delta j, delta I, are these unknowns? Yes. So if you look at each bus, let us look at any bus. What are the variables associated with this bus? So this is the net power injected into the bus, Ei and Qi, and these are the voltages of this bus, Vi and delta I. So with each bus, we have 4 variables or 4 quantities, Ei, Qi, modulus of Vi and delta I, angle. And if we have got n such buses, so for n bus, we would have 4n variables. And how many equations we have? And we have got 2n equations. So can we solve this system? We have got 4n variables or unknowns and 2n equations. To solve any system, we must have equal number of variables. So we must have 2n variables and 2n unknowns, 2n equations. Then only we can solve this, right? If we have got 4n variables and 2n are the number of equations that are available, we cannot solve this system. So what we do? We have to freeze, or we have to assume somehow that we know these 2 variables. 2 of the out of this variable. So what are the variables? EI, UI, VI, delta. So out of which, unless and until I assume that for each bus, if there are only two unknowns, two are known quantities, then only I will have 2n equations and 2n unknowns. So there are various combinations in which we can do this. That out of this 4, we can have any 2 as known, or we can assume that we can know any 2 variables and the other 2 are unknown. So one combination is, I am just listing out all the combinations. This is known, this is known, this is not known, this is not known. Then this is known, this is known, this is not known, this is not known. Then, can there be any more? Then one can be, this is known, this is known, this is unknown, this is. There can be other also. Okay. So I just can write few more, if not all. For example, I can say P and delta are known and these are unknown. Or I can say Q and delta are known and these are unknown. Any other combination you can suggest? Q and V are known, P and delta are unknown. Any other combination? Have we covered? It will be repetitive. So I guess mostly these are the combinations. But out of this combination which I have listed here, these are the typical combinations that are used. So these are the feasible combinations. Why I call it feasible? Because it must be realistic combination also. Take for example, I have listed the first one. So this is the most common configuration that we know what is the load at a particular bus. So whenever is the load at a particular bus is known, that PI and QI are known. Assume that there is no generator connected. Then the unknowns are what will be the voltage at that bus and what will be its angle. Okay. So this type of bus is called as PQ bus, where this is also called as load bus, where what is known, what is P is known, what is the load at that bus, real load, what is the reactive load, that is known, and what we have to find out, what is the voltage magnitude and voltage. Then the second combination is PI is known, VI is known. and Q and delta are unknown. So this type of combination is known as a PV bus. Or a generator bus. It is also known as voltage control bus. But this is also a realistic situation. In actual power system, we will have this combination, we will have this combination. Now, why it is this combination I have selected? That we know what is the real power, we know what is the magnitude of the voltage, and the reactive power at that bus and its angle, that is not known. So this typically happens in a generator bus where we know that the generator set is let us say 220 megawatt set. So what is the maximum real power that we can have? 220 megawatt. Can it give us a power, real power less than 220 megawatt? Yes, it can give us. Let us say 150 megawatt power we can set that this generator should give 150 megawatt of power. How do we set that? We set that by controlling the inlet to the generator. What is the inlet? The steam. So the steam to the turbine. Okay. How much steam should follow on the blades of the turbine, that we can control, and depending upon that energy, the mechanical power will be supplied to the generator and it will translate that into electrical power. So how much that should be, that we can control by controlling the steam valves of the turbine. So it can, if we close the steam valves to a great extent, then the real power produced will be very less. So we can control that real power at the generator. Also, we can control the voltage magnitude of that generator by how do we control the voltage magnitude? Voltage magnitude we can control by adjusting the field current. Okay. You know that the voltage induced is 4.44 F by N proportional. Okay. So it is proportional to F, it is proportional to N, it is proportional to phi. What is phi? Phi is the flux. So phi is the flux. So V is proportional to F by N. This is number of turns. This is the frequency and this is the flux. So how we can control the flux in a DC shunt generator, let us say? If we can control the field current, IF or field current. You know that this is a typical in a machine. We can control that using how much current should go into the field winding by just have a resistor there, and by that resistance you can control. Simple way. There can be other ways also. I am just discussing one. So field current you can control. If you control field current, you can control the flux. If you can control the flux, you can control the voltage magnitude. So this voltage magnitude is controllable by adjustment of field current. So we can control this, we can control this, and then we will have this as unknown. So this is called as PV bus or a generator bus, because generally at the generator bus these are the functionalities available. Also it is called as voltage control bus. This voltage control bus is typically the bus where we don't have a generator, but we have certain capacitance or inductance unit attached to that. So we can control the voltage of that bus by switching on the capacitance or inductance. If you switch on the capacitance, you will get a rise in voltage. If you switch on the inductor at that bus, you will get a dip in the voltage. So you can control the bus voltage using the capacitor and inductor bank. So that is called as voltage control bus. and at that voltage control bus the power is zero because there is no generation. So power is zero, but you can control the voltage magnitude at that bus. So this is also a case when we have got a voltage controlled bus. So these are another bus, and this is the third kind of bus where we what we know is what is voltage magnitude, voltage angle, and PI and QI, they are unknown. This is called as the reference bus or slack bus. So generally we'll come to that why we need this reference bus, but in general, like we measure the voltage magnitude with respect to ground, we measure the voltage angle with respect to a certain bus that we call as reference bus. So the voltage magnitude of that the angle of the reference bus or slack bus we are taking as reference, and angle of all the other bus voltages, they are measured with respect to that. So in which case we have got this voltage and delta fixed. Generally the largest bus is selected as slack bus. Largest generator is selected. This is convention, not necessary. Mathematically, absolutely not. So these are the three major types of buses. Now, why we should have or why we are discarding this other combinations why I discard. There can be more combinations also. I am not writing all, but just I am putting before you some combinations that are possible. So why we are discarding this? So these are not feasible combinations. Remove this, get more space to write. So these are not feasible combinations. Why these are not feasible combinations? For example, I am saying that I know Pi and delta I. Okay. And I can have the unknown as Qi and Pi. But as you can see, if we have seen in the circle diagram also, that P and delta, they are closely related. For example, we know that in a two-bus system, so if this is voltage is E angle delta, this is V, and this is X. We have derived this. The power at the receiving end is E V by X sine of delta. EV by X sine of delta. So since there is no loss here, this PR, okay, this is PR. This PR is same as this PR, or this will be PG. So this PG is, I can also write this as PG now. So if I know what is the power injected, it is related to delta by this equation. So these are these truly independent variables? Pi depends on delta I. These are related, they are not independent variables. So what we need to do is we should need to select the variables which are independent of each other or which can be controlled independent of each other. The moment you fix PG here, your delta will automatically get fixed if these, depending upon these voltages. So one should not be a function of other. So in all these cases, for example, take the next case. Q uh, this case Q and delta. Now you cannot really control delta. Delta as doesn't have any mechanism to have an independent control. Q you can have by changing the field current, you can little bit change the Q, but delta you cannot, you don't have any mechanism that set delta to 20 degrees. You don't have that mechanism in power system. You have the mechanism in power system that you can set the power to a particular, real power to a particular, but you don't have a mechanism in the power system that you say that I will set delta to this way. It is just not feasible combination. There is no control mechanism by which we can say that this is known, we can set. So when I'm saying that this is a feasible, not feasible combinations, so it is because of two reasons. That one reason is like this, that these two quantities are dependent on each other. So we should have an independent variable. So in only independent variable can work. If they are dependent, then I cannot set them different. I cannot set P as this much and then I will set as delta as 30 degrees and P as 150 micron. Because the moment I set P, this delta is a function of P. So I cannot, because you can always argue that why VE and V, they are the unknowns in this case. So P and delta are known, E and V are unknown. Okay, they are unknown, but by how much they are going to vary? They are going to vary by plus minus 5%. Okay. So that is not going to be a big deal. You cannot, so more or less, there are limitations on each. So you cannot have an independent control of PG and delta. Okay. So this is a, so either they are not independently controllable, they are dependent on each other, or such a combination is not possible because there is no separate control mechanism that exists. For example, as I said, Q and delta. So I cannot independently control delta. I cannot control, there is no mechanism to set delta to 20 degrees at a particular bus. I can't. There is no mechanism with it. So these are non-feasible combinations. Only these three are feasible combinations. So therefore, these are the different kinds of buses that we have. Okay. Now I will have another look at these equations. So Pi and Qi. One more thing that, so at least now we have settled that we will have exactly the same number of unknowns as the number of variables, equations. So we can see what are the feasible things and we can determine depending upon the type of buses which two are unknowns, which two are known. So we can select any of these three combinations depending upon whether there is a load connected at that bus, whether there is a generator connected at that bus, or whether we want that bus as the reference bus where we can control the voltage and we set the angle to a reference angle by which the other angles will be measured. So these are the three types of buses, and in the next lecture we will continue this and let us see there are some more trick or there are some more problems in solving this load flow. It is not so simple to solve this. Okay, so I will stop the recording here. First stop the sharing and then stop the recording. So how to stop the sharing? Let me see. Yes, so I will stop this sharing as I have done here, and then I stop the recording.